On the internet, the algorithms are all around you. You are watching this video because an algorithm brought it to you, among others, to click, which you did, and the algorithm took note. When you open the tweetbook, the algorithm decides what you see. When you search through your photos, the algorithm does the finding, maybe even makes a little movie for you. When you buy something, the algorithm sets the price, and the algorithm is at your bank watching transactions for fraud. The stock market is full of algorithms trading with algorithms. Given this, you might want to know how these little algorithmic bots shaping your world work, especially when they don't. In ye olden days, humans built algorithmic bots by giving them instructions the humans could explain. If this, then that. But many problems are just too big and hard for a human to write simple instructions for. There's a gazillion financial transactions a second. Which ones are fraudulent? There's octillion videos on NetMeTube. Which 8 should the user see as recommendations? Which shouldn't be allowed on the site at all? For this airline seat, what is the maximum price this user will pay right now? Algorithmic bots give answers to these questions. Not perfect answers, but much better than a human could do. But how these bots work exactly, more and more, no one knows. Not even the humans who built them, or built them, as we will see. Now, companies that use these bots don't want to talk about how they work because the bots are valuable employees. Very, very valuable. And how their brains are built is a fiercely guarded trade secret. Right now, the cutting edge is most likely very I hope you like linear algebra, but what the current hotness is on any particular site and how the bots work is a bit I don't know, and always will be. So let's talk about one of the more quaint but understandable ways bots can be built without understanding how their brains work. Say you want a bot that can recognize what is in a picture. Is it a B or is it a 3? It's easy for humans, even little humans, but it's impossible to just tell a bot in bot language how to do it, because really we just know that's a B and that's a 3. We can say in words what makes them different, but bots don't understand words, and it's the wiring in our brains that makes it happen anyway. While an individual neuron may be understood and clusters of neurons' general purpose vaguely grasped, the whole is beyond. Nonetheless, it works. So to get a bot that can do this sorting, you don't build it yourself. You build a bot that builds bots and a bot that teaches bots. These bots' brains are simpler, something a smart human programmer can make. The builder bot builds bots, though it's not very good at it. At first, it connects the wires and modules in the bot brains almost at random. This leads to some very special student bots sent to TeacherBot to teach. Of course, TeacherBot can't tell a B from a 3 either. If the human could build TeacherBot to do that, well then problem solved. Instead, the human gives TeacherBot a bunch of B photos and 3 photos and an answer key to which is what. TeacherBot can't teach, but TeacherBot can test. The adorkable student bots stick out their tongues, try very hard, but they are bad at what they do. Very, very bad. And it's not their fault really. They were built that way. Grades in hand, the student bots take a march of shame back to BuilderBot. Those that did best are put to one side, the others recycled. BuilderBot still isn't good at building bots, but now it takes those left and makes copies with changes and new combinations. Back to school they go. TeacherBot teaches, tests again, and BuilderBot builds again. And again, and again. Now, a builder that builds at random and a teacher that doesn't teach, just tests, and students who can't learn, they just are what they are, in theory shouldn't work, but in practice it does. Partly because in every iteration, BuilderBot's slaughterhouse keeps the best and discards the rest, and partly because TeacherBot isn't overseeing an old-timey one-room schoolhouse with a dozen students, but an infinite warehouse with thousands of students. The test isn't 10 questions, but a million questions. And how many times does the test, build, test, loop, repeat? As many as necessary. At first, students that survive are just lucky, but by combining enough lucky bots and keeping only what works, and randomly messing around with new copies of that, eventually a student bot emerges that isn't lucky, that can perhaps barely tell B's from 3s. As this bot is copied and changed, slowly the average test score rises, and thus the grade needed to survive the next round gets higher and higher. Keep this up, and eventually from the infinite warehouse slaughterhouse, a student bot will emerge who can tell a B from a 3 in a photo it's never seen before pretty well. But how the student bot does this, neither the teacher bot nor the builder bot nor the human overseer can understand, nor the student bot itself. After keeping so many useful random changes, the wiring in its head is incredibly complicated, and while an individual line of code may be understood and clusters of code's general purpose vaguely grasped, the whole is beyond. Nonetheless, it works. But this is frustrating, especially as the student bot is very good at exactly only the kinds of questions it's been taught to. It's great with photos, but useless with videos, or baffled if the photos are upside down, or things that are obviously not B's it's confident are. Since TeacherBot can't teach, all the human overseer can do is give it more questions to make the test even longer, to include the kinds of questions the best bots get wrong. This is important to understand. It's a reason why companies are obsessed with collecting data. More data equals longer tests equals better bots. So when you get the "Are you human?" test on a website, you are not only proving that you are human, hopefully, but you are also helping to build the test to make bots that can read or count or tell lakes from mountains or horses from humans. Seeing lots of questions about driving lately? What could that be building a test for? Now, figuring out what's in a photo or on a sign or filtering videos requires humans to make correct enough tests, but there is another kind of test that makes itself. Tests on the humans. For example, say entirely hypothetical NetMeTube wanted users to keep watching as long as possible. Well, how long a user stays on the site is easy to measure, so TeacherBot gives each student bot a bunch of NetMeTube users to oversee. The student bots watch what their user watches, looks at their files, and do their best to pick the videos that keep the user on the site. The longer the average, the higher their test score. Build, test, repeat. A million cycles later, there's a student bot who's pretty good at keeping the users watching, at least compared to what a human could build. But when people ask how does the NetMeTube algorithm select videos, once again, there isn't a great answer other than pointing to the bot and the user data it had access to, and most vitally, how the human overseers direct TeacherBot to score the test. That's what the bot is trying to be good at to survive, but what the bot is thinking, or how it thinks it, is not really knowable. All that's knowable is this student bot gets to be the algorithm because it's 0.1% better than the previous bot at the test the humans designed. So everywhere on the internet behind the scenes there are tests to increase user interaction, or set prices just right to maximize revenue, or pick the posts from all your friends you'll like the most, or articles people will share the most, or whatever. If it's testable, it's teachable. Well, teachable. And a student bot will graduate from the warehouse to be the algorithm of its domain, at least for a little while. We're used to the idea that the tools we use, even if we don't understand them, someone does. But with our machines that learn, we are increasingly in a position where we use tools or are used by tools that no one, not even their creators, understand. We can only hope to guide them with the tests we make. And we need to get comfortable with that, as our algorithmic bot buddies are all around and not going anywhere. Okay, the bots are watching. You know what's coming. This is where I need to ask you to
Guys, in today's video, we are just going to discuss the second part of soft computing. That is, what is the difference between hard computing and soft computing? So there are various differences. The first difference that is there is soft computing is tolerant of imprecision, uncertainty, partial truth, and approximation. Okay, say as you can see in this diagram, we have two options. Either we can go to this way or we can go to that way. So in that case, generally what our mind will think, how generally we will think that in which way we have to move, right? If it is hard computing, then in that case it should be completely precise, right? It should completely tell you that in which direction you have to move. But in soft computing, we can mold it according to our need, according to our destination and goals. So we can have different options and we can choose the best of them. That's why it is soft computing. So there is nothing certain here. It's not completely truth. and generally something approximate, not completely fulfilled. So in that case, what type of computing we are using is soft computing. Second difference is that it is based on fuzzy logic and neural sets and probabilistic reasoning. Whereas if you will talk about hard computing, that is based on binary logic. Let's take a normal example of fuzzy logic here. As here in this diagram, what you are seeing, we have two inputs 0 and 1. So you can get one output something like zero point 0.7. Okay, zero point 0.7 is in between 0 and 1. So if we are taking 0 as cold water and 1 as hot water, then in that case, their mixing will give you something like warm water. Okay, that is what fuzzy logic is. It is giving some value that is not completely precise, that is not completely exact value. While in binary logic, if you're talking about hard computing, in this case, we have only two options. Either it will be hot or it will be cold, right? So we don't have any other option in that case. We are completely precise here that exact value of hot or cold you will get. You cannot get anything in between of these. But in soft computing, we have this kind of option. Beyond fuzzy logic, we have neural network, neural sets, and some probabilistic reasonings by which we can apply different concepts in soft computing. We can have some reasoning on the basis of probability that we can get some specific results that you cannot get in hard computing. The third difference is soft computing can evolve its own program. See, this is one of the very important topic or concepts we can say, that soft computing have the capability of developing their own programs. We have already discussed that the role model of soft computing is human mind. So as human minds can develop or evolve their own programs, their own instructions, softwares, or whatever you can say, so same soft computing can also do. Whereas if we are talking about hard computing, then they generally require some pre-written programs in which it will work. And in that case, they have some fixed set of instructions that it will follow. If anything that is going beyond the instruction, your hard computing software or anything which is belongs, which is depends on hard computing will be stuck. It will not going to work beyond that. But in soft computing, you have the capability. It has the capability of learning by its own. It has the capability of evolving its own programs and so on. The fourth one, soft computing incorporates stochasticity. That is, the patterns that may be analyzed statically but may not be predicted precisely. You can analyze them using some statistics, but you cannot precisely predict what the output will be, what that pattern will be. For example, in this diagram, you can see the diagram of a lady. So if someone asks you what is the age of this lady, you cannot predict precisely that this lady is specifically of 30 years or 31 or 32 or 25 years. Right? You can analyze it statically by seeing the color of hair, by seeing the skin texture and so on. But you cannot predict precisely the age of that person. That's what soft computing used. Right? Whereas if you're talking about hard computing, it is deterministic. That is, it's sure. Say in this array, if someone asks you if 5 is available in this array or not, yes, it is deterministic. Either it will be there or it will not be there. Right? So this is what another difference between soft and hard computing. The fifth one is soft computing can deal with ambiguous and noisy data. Again, in this diagram, you have something ambiguity here. It could be read it as 13, or it could be someone read it as B. So there are two different options. Soft computing can deal this kind of ambiguity. Whereas if we talk about hard computing, then it requires exact input data. If it is B, then it should be B. It could not be 13 in that case. But soft computing do have the capability of understanding or differentiating between two different options from one diagram. Sixth difference, soft computing allows parallel computation, right? As our mind do. You know that at a time we can do different works through our mind. Okay, and our mind do have some parallel computation concepts. That is because we are able to see different things, we are able to listen, we are able to talk, and so on. That is only because of the parallel computations of our mind. And same concept we can achieve with the help of soft computing. While using hard computing, it is strictly sequential. We cannot have parallel computations or parallel things in hard computing. And that is why, in spite of having so many very good speed, very good technology, and so on, computers are not able to achieve what humans can basically achieve, the things like the artificial vision, or listening the things, or understanding the things, and creating the programs, reading, and so on. So, with the help of parallel computations, we can achieve this kind of activities. And the seventh one is soft computing can yield approximate, or it basically yield imprecise or inexact answers, not exact answer. As in this diagram, say someone is asking you what will be the depth of this river. So you cannot give precise answer. Okay, so in that case, you will just guess some answer. But if we are taking the concepts of hard computing in this one, we have some specific equipments and devices, then using that, we can produce some precise answers, some exact answers in that. Right, so guys, in this video, what we have discussed is what are the different differences between soft computing and hard computing. Till yet, different kind of programming or concepts that we have learned was very much emphasized through the hard computing concepts. But using soft computing, what we can do is we can just duplicate our mind. We can do the activities that human minds can do. So soft computing do have a very bright future, and I just recommend that you all should go to soft computing and you all should work differently. You all should work so concentrately in this one so that you could do something big in this area. So guys, in next video we will just discuss the introduction of fuzzy logic. So till then, please like, share, and subscribe. Thank you very much.
If a person from 1750 was transported to 2016, he wouldn't recognise the world. The industrial and technological revolutions have changed society significantly. If we were transported to 2050, perhaps we'd see the same amount of progress in just a few decades. Just as smartphones and Skype would be unthinkable for someone from the 18th century, we may have the same reaction to the technologies being developed right now for use in the near future. Artificial intelligence is likely to be the next big revolution that changes the world we live in. Artificial intelligence means machines and computers that can act intelligently and display behaviours that we'd normally only associate with humans. For example, being able to hold a conversation in English or being able to make decisions based on our environments. AI is all around us and we use it every day without realising. You just have to know where to look. For example, something you probably take for granted is the recommended friends feature on Facebook. Data about your interests, locations, statuses, events, and even searches are collected, and AI is used to analyse this information to suggest people you may know. Facebook do a lot of research into how to analyse and process large amounts of data, and artificial intelligence can be used to make this faster and make the data more useful. It can spot patterns in locations people go to and draw connections between people. Another application of AI that is in the news is self-driving cars. To drive without humans, the cars need to be able to recognise objects and obstacles on the road and find the shortest path from A to B. Therefore, much of the research being conducted in this field is to do with computer vision and pathfinding technologies. When we're travelling abroad, Google Translate can help us talk to the locals. This uses natural language processing, an area of research in artificial intelligence that allows computers to process information in a natural language like English instead of a computer programming language. This means that Google Translate can recognise speech, detect the structure of sentences, translate them, and then generate sound. A large body of research focuses on how we can get computers to better understand natural languages, using circuits that try and mimic our brains. Much of the UCL Intelligent Systems research is also in the field of natural language processing. One of their projects is Reinfer, a tool that automates customer support. Customers can message a chatbot with questions about a business or a website, and they receive responses that could have come from a human. All research in AI, both inside and outside of UCL, focuses on improving the efficiency of algorithms so that more complex programs can run on cheaper hardware, use up less memory, and take less time to run. Currently, we can solve many complex problems with artificial intelligence, but AI falls short when it comes to tasks that as humans we take for granted. Things like recognising shapes and drawing conclusions from information are currently beyond the capability of much of the AI technology we have. The next big steps in AI will come when computers have the power to reason and make their own decisions. Computers are good at solving singular, difficult problems, but if you show a picture of a car crash to a chess program, it will not know what to do with it. It's only good at playing chess. Therefore, a big breakthrough will come when we can create single programs that can perform multiple tasks that humans can perform. This will take computers closer towards being truly intelligent. No one can predict what the future holds for AI, not even the researchers who devote their lives to the field, but to find out more, go to our website.
In 2016, we made a video on top 10 technology trends in 2017. We predicted that AI, that is artificial intelligence, will gonna be the future in technology. And guess what? In 2017, the market for artificial technology is flourishing. Numerous startups and internet giants are racing to acquire them. There is a significant increase in investment and adoption by enterprises. Watch this video till the end and we will tell you top 10 hottest artificial intelligence technology. Hey there, this is Gaurish from Snappy Techie. Let's get started. The first technology is natural language generation, which is basically producing text from computer data, which is currently used in customer service and summarizing business intelligence. The second technology is speech recognition. It deals with transcribe and transform of human speech into format that is useful for computer application. It is currently used in interactive voice response systems and mobile application, which you currently see on your mobile phones. The third technology is virtual agents. It is the current darling of the media. Currently it is used by big firms like Amazon, Apple, Google, IBM, Microsoft, etc. The fourth is machine learning platforms. Machine learning platform provides algorithms, API development, training toolkits, data, as well as computer power to design, train and deploy models into application. It is currently used in a wide range of enterprise applications, mostly involving prediction or classification. Example, now sample vendors are Amazon, Microsoft, Google, etc. Fifth technology is AI optimized hardware. Now, graphic processing unit, that is GPU, and appliances specifically designed and architect to efficiently run AI computational jobs, currently primarily making a difference in deep learning applications. The sixth technology is decision management, engine that insert rules and logic into artificial system and used for initial setup and ongoing maintenance and tuning. This is a mature technology. It is used in a wide variety of enterprise applications, assisting in or performing automated decision making. Seventh technology is deep learning platforms. This is the special type of machine learning consisting of artificial neural networks with multiple abstraction layers. Currently, it is used in pattern recognition and classification applications supported by very large data sets. Eighth technology is biometrics. Many of you may be familiar with this. Biometrics enable more natural interaction between humans and machines, including but not limited to image and touch recognition. It also does speech and body language, currently used primarily in market research. Ninth technology is robotic process automation, using scripts and other methods to automate human action to support efficient business processes, currently used where it is too expensive or insufficient for human to execute tasks or process. The last technology is text analytics and NLP. Natural language processing, that is NLP, uses and supports text and analytics by facilitating the understanding of sentence structure and meanings, also sentiments and intent through statistical and machine learning methods. So there it is guys, this was the top